Okay, so we're going to start looking at systems of equations, and the first topic that we will cover are the solving of systems by graphing them. So any ordered pair xy that satisfies both equations in a system of linear quadratic or quadratic-quadratic equations is the solution of the system. So for example, the points 2, 4 and negative 1, 1 are solutions of the system y equals x plus 2 and y equals x squared. So what does that mean? It means that these 2 points, 2, 4 and negative 1, 1, are the points of intersection between these two lines. Okay, so they are the points of intersection between the lines. So if we take a look at the graph on the right, the blue line is the linear function, so y is equal to x plus 2. And the red line is the quadratic function, which is y equals x squared. And their points of intersection are 2, 4, and negative 1 and 1. So here we have 2, 4, and negative 1 and 1. Now, if they are solutions, then they will satisfy both equations. Okay, so that means that the point 2, 4 should satisfy both y equals x plus 2 and y equals x squared, and the point negative 1, 1 should also satisfy both y equals x plus 2 and y equals x squared. So let's try that out. Y is 4 and x is 2, so we will substitute that into our linear function. And we get that 4 is equal to 4, so that works. And then if we plug that into our quadratic function, so y is 4 and x is 2, then we get 4 equals 4 again, and so that works. Alright, let's try the point negative 1 and 1. So for our linear function, y is 1, x is negative 1, and so we get that 1 equals 1, so that works. And then for our quadratic function, y is 1, and x is negative 1, and we get 1 equals 1 again, and so that works. Okay, so if the points are truly solutions, then they will satisfy both equations, okay? And both points will satisfy both equations. If you graph them, you'll see that they are the points of intersection. Okay, so how many solutions can you have? Well, a system of linear quadratic or quadratic and quadratic equations may have no real solution, one real solution, or two real solutions. And a quadratic-quadratic system of equations may also have an infinite number of real solutions. Okay, so what does it mean when we have no solution? Well, if we have no solution, we have no point of intersection. So that means when you draw a line, you just have to draw it so that it doesn't intersect the other line. Okay, so our two lines will not intersect each other. That means no point of intersection, no solution. What does it look like when we have one point of intersection with a line in a quadratic? Okay, well, it could look something like this. You could have a line go through. Oops, let's get a little closer. And have it touch at exactly one point. That would mean we would have one solution. Okay. Now with this one, if we have one point of solution, or sorry, one point of intersection, then we call this the point of tangency. Okay. And tangent to the curve means when a line touches the curve at one point, okay, so like this one here. All right. Now, if you have something like this, okay, so let's say you've got your line and you have another line that is going to intersect it like this. So you have something that goes like this, it comes up, and goes down, and you have a point here at, we'll call it D, and you have a point here at E, then this one is a point of tangency. Okay, because it touches the blue line. The red line touches the blue line at one point. If the red line actually goes through the blue line, that's not a point of tangency. Okay. All right, and our last situation is that we have 2 points of intersection, which means we would have 2 solutions, so that when you draw a line through your parabola, you would have to have it intersect at 2 points. Okay, so we've got 2 points here, one here and one here. Okay. Now, if you take a look over at the sidebar on the left, what would the graph of a system of linear quadratic equations with an infinite number of solutions look like? Well, you think about this, okay? Here is our parabola. Is there any other situation besides these 3 that we have, no point of intersection, 1 point, and 2 points, that would result in an infinite number of solutions? And the answer is no. There's no way that I can draw that line that it would cross or map onto our parabola in an infinite number of points. Okay, so this is not possible. Okay, our only 3 possibilities are no solution, 1 solution, and 2 solutions. Okay, let's take a look at a quadratic and a quadratic. No point of intersection would result in no solution. Okay, so we could either have, like in this particular example, we could have a parabola that opens down like this. Okay, there's no point of intersection between the two. Or we could have one that opens up inside this one, and as long as the vertical expansion is greater than the red line, okay, it'll never cross over. Okay. All right, 1 point of intersection, meaning 1 solution. Well, in this case, you could have a parabola that opens down and it touches at the vertex at 1 point only. Okay, like that. And so we have 1 point of intersection here, and yes, this is a point of tangency. Okay, and our last situation is 2 points of intersection, 2 solutions. In this particular case, it could look something like this. All right, so you have a point of intersection here and 1 here. It's not the only way that you can draw it, it's just one of the ways that you can draw it. Okay, so I will conclude this discussion here, and then we will take a look at using our graphing calculators to solve a linear and quadratic system.